to be here today with you all. Thanks for that awesome introduction. I'll talk a little bit about my journey, and then I'll talk about a couple key principles that I found to be super helpful, super useful on the journey to do the top-notch intellectual, rigorous, and scholarly work, and make those contributions to the world. So, when I started on this journey, I didn't necessarily set out to be a researcher or to be a professor or to even start a company. As I was going through kind of my early years in education, it really started with just a burning desire to do cool stuff, right? To tinker, to explore. I thought I was goofing off, right? I goofed off all through high school. I was working on a couple crazy projects. There was one project called QRMG, the Quake Random Map Generator. I learned C++ so I can write that tool, so that I can automatically have procedurally generated levels to play in Quake. And then that turned into URGE, the Universal Random Generation Engine. I actually had like 15,000 users of Quake Random Map Generator when I was in high school, and I went to a high school where I was, about, 2% went to college out of this school, and I was the only person that would talk about C++ all the time. And so I worked on that project, and I derived all my dopamine from the fact that I had users using the thing, and I would send 6-hour updates. Every 6 hours, I would be sending updates as to new features I've added, new kinds of levels, new kinds of monsters. Oh, there's stairs now. And that's why I didn't do so well in high school. No. I did decently well, right? Well enough to get into University of Pittsburgh and a couple other universities. I ended up going to Pittsburgh because I wanted to get far away from home, from Michigan. But, so I had this tinkering thing, and then I was working on a language called Snupple. I learned to write virtual machines and all, and I wanted to write a virtual machine that moved geometry around. And then you could write a language where you can express procedurally generated things, all of that. So I went to college. And my parents always promised me, I didn't want to go to college for a bit. My parents always promised me, oh, you're going to find people like yourself at college. And I was like, okay, I'll wait, right? And then I went to college, and that was a whirlwind of experience, right? Like, I was not very cool. I didn't, have the ladies in high school. I didn't have much going on socially. And then I went to college, and then that's when I had my first shot of Smirnoff. And then I discovered there was a frat, and I just went on a wild journey, right? But all the meanwhile, I had my side projects, my little side projects that I was super passionate about. And, for me, that was play, that was goofing off. That was like not doing the institutionally established thing that I should be doing, which is trying to get a 4.0 as hard as possible. But I ran into I was showing it off to a professor, and I was like, look at this awesome language that I created, and the VM. And I had a visualizer where you can see the bits changing and the values in the registers changing as you executed this program. And I just thought it was the coolest thing ever, that you're creating these interesting machines in software. And I showed it off to a professor, and they're like, you have to meet Mary Lou Sofa, right? This was when I was a freshman. And I met Mary Lou Sofa, and Mary Lou Sofa was like, Stay for the summer, I'll give you $4,000 to do this kind of stuff all the time. And I was like, whoa, what's going on? You can actually be celebrated for doing this kind of work? This is a thing? And that's how I discovered research. And I went through, every summer, I did research in our lab. All through the year, I did research on the journey to get a paper. You get, this culture hits you where you learn that there's an institutionally validated, vindicated way to tinker and explore and discover, and you have to learn the technique of applying rigor and good science and scholarship to your work. And when you do it in those kind of rails, you get to do that all the time. And I was like, oh my God, this is my life's work, right? I have to do this kind of stuff. You get to pick the problems you think that are most pressing, and really apply good science to those problems. So I did it every summer, and at the same time, I was a DJ in the electronic music scene. Pittsburgh has a really great drum and bass and house scene, and I was DJing. I was playing raves. I would go out and open shows for like big acts. They're not big anymore because like BT was huge, right? And Aker and Real Time was massive drum and bass DJs, and I like opened for them, and it was awesome. And I was like, all right, when I'm done with college, I have one or two choices. I can go to grad school and be a PhD, or I could go to be a superstar DJ, go to Orlando or Fort Lauderdale. There was a big scene there, and then try to get over to the Love Parade in Europe somehow. That's like DJ ambitions. Luckily, I got robbed by another DJ. Like he just stole all my gear, right? That helped my decision be much easier. I accumulated all this gear, and you're obsessed with all your synths and your decks and all the the toys. And then this guy just came and like took all my stuff, and I was like, I don't know if I'm into this lifestyle. I'm gonna go ahead and take Mary Lou Sofa up on her offer to join our research lab. So it was an interesting journey, right? It was an interesting journey of exploration and discovery, and research really was something that I cared about doing beyond achievement. It was something that I cared about doing for the sake of doing something awesome that could be shared with the world, right? And so when you join grad school, it's important to understand why you're joining grad school, right? It's important to understand what calls you. And I'm going to talk about a number of things, some of them controversial, some of them not so controversial. Just to wrap up the story, I became a professor. There's some of these tenets that really helped me build a great research group and a great culture, and I'll talk about what great cultures look like from my perspective. And we did some phenomenal work in the way we approached research and the way we would execute research. And at some point when you have made a lot of contributions, at least for me, it was critical to try to do something that can touch people's lives, like at scale, right? And so ultimately ended up creating a company, Clink, after a few years of my academic pursuit. Worked with like 14 PhD students in that time, and we started this thing that could be a platform for us to impact the world, and it's been going really well. And now we're 100 people in a couple continents, offices in San Francisco and Beijing and LA, and it's a wild ride, right? We have 31 million people have our technology in front of them, and that'll grow to about 70 million this year. So that's good. And so having that impact, the thing I'm most excited about that journey is the research lab that we've created inside the company, right? We've architected the company almost around a research lab where there's a mandate that you publish, and then there's a mandate that you publish again with data from the product's success, right? So then you get your stuff into product. It's really interesting. I can talk about that offline. Now, here are the things that I really discovered along the journey that created a path for me to succeed. I'll tell you, when I started as a researcher, I didn't understand that you had to publish top-tier papers, right? There's 100 computer science conferences, and whoever's mentoring you will set the tone of what matters, and you will learn what matters from them. That's why I have to choose wisely. And the reason I mention that is that I came upon that discovery, and someone who cared about me said, Jason, you have all these big dreams, but you don't have top-tier papers, and really, those top-tier papers is what's going to determine your possibilities moving forward. And I was like, oh crap. So I got to publish top-tier papers if I want to really be able to enjoy this lifestyle at its fullest. The person who told me that was John Carmack. Not John Carmack, what am I? John Cavazos. John Carmack used to, but John Cavasso, I don't know if you guys know, John Cavasso passed away. I was shocked. He passed away, I think he was struggling with cancer. But that was 2 years ago. And he was a light in the community. And he was Hispanic, super successful, incredibly charismatic, incredibly talented. He made some game-changing contributions when it comes to, he started using machine learning for compiler research before there was the hype that happened with machine learning. Maybe 5 years before the first, oh my God, machine learning is cool thing happened, he was publishing papers using those insights. But why am I talking about John Cavasso and that moment? Those moments is a foundation that will set the tone of your career and what you're able to achieve. And really what I'm talking about is mentorship and identifying good mentors. That is the number one most important thing that I have done well, that has given me the ability to grow and engage the world at higher and higher levels. It's the trail of unlikely mentors along the way. So if John Cavasso wasn't my friend, and if he didn't have an irrational care for me, and that's what you look for, how do you know you have a great mentor? They should care for you in ways that are not rational, right? Really, it's like they don't expect you to do anything for them or for their career. They have a curiosity and an interest in you because some irrational love of people or some irrational care. And some people have strong mentorship muscles, and they care about that. And you look for that. I looked for that all the time. So Mary Lou Sofa was my first true mentor. Was a guy named Naveen Kumar. He's at Google right now, and he was a grad student in Mary Lou Sofa's group. So when I joined that first summer, we would go get food at the food truck in Pittsburgh like every day. And we grew a friendship, and we talked shop talk all the time. And I was learning what a paper was and why you have to have like an abstract and an introduction. And, like simple things. But he took this irrational care in me, and he challenged me. I remember during the summer, he was like, Jason, I think you're a prodigy, but you're slacking off on this thing, right? We were doing a triple modular redundancy in Strata for binary translation, right? So that's a mechanism for transient faults. When transient faults hit your airplane chip, you don't want a bit to flip and then your plane nosedives, right? So what you do is you can have dynamically 3 versions of the same program executing, and you're checking store values as it executes, and you're voting. Triple modular redundancy, 3 threads, you vote, and you take the best value of the 2, and that adds an incredible amount of security without adding hardware, right? Good. It's slow as hell, though. It costs a lot in execution. Anyway, so I was implementing that in a binary translator, and I really was lollygagging, right? So then he just said one thing to me, you're messing up here. And then I stayed up for like 2 nights straight and slept under the desk and implemented working triple modular redundancy. I don't know, the paper never happened, probably because it was too slow. But, and there's competing techniques, right? Run ahead threads and all kinds of stuff with voting and so forth. But that care that we built with each other empowered his voice and the impact that good guidance could have on me. Because if I just met him on the street, hey, buddy. And then I was like, yeah, I didn't implement this thing yet. And he was like, dude, you need to go implement that. I'll be like, all right, thank you. And then I would continue, okay, maybe. But when you build that trust, that rapport with someone, the power of their guidance, especially when you believe in them and you get it, is phenomenal. He was one of the first mentors. There's a trail of these folks. There's Robert Hunt, right, at Google. He challenged me to create a research lab. I was in grad school. I didn't know what the heck I was doing. A research, what was it? What's Kuhnle's thing? Oh my God, I forget what it was called, but there's some kind of like Stanford lab, blah, 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 and companies will push money into the lab, and then it's great, right? And I was like, oh man, I should create the data center research lab at University of Virginia, and I didn't know that like PhD students couldn't do that. Thank you. I tried to create that lab, and we got like a Google grant in it. Thank you, Robert. Thank you, Google. And my advisor was just delighted. She was like, sweet, this kid's doing all this cool stuff and money's coming in, all right. But he challenged me to do something. He just had a chat with me and he was like, Jason, what you really need to do, you need to do that thing that Kuhnle is doing. I mean, look at Stanford. They're getting millions of dollars from all over the world building this big research lab. And I was like, oh my God, that's an interesting point. Let me give it a shot. I mean, these folks grow you, right? And when you engage them well and you engage them right, you're going to be able to be the best version of yourself possible. And that's really what we should strive to do, right? I mean, getting into research right, getting on this intellectual journey right, it goes beyond, it's not a job,
And it's not that thing you do over here, and I'm going to balance work-life balance. It becomes a part of your constitution. It becomes a part of who you are. And so you grow, it's a you growth, right? You grow with principles of truth and evidence, right? What is the truth? You grow with a principle of creativity. Okay, I got on this journey, and now I'm starting to learn. You learn more on the journey, whether you have the right answer or not. You learn more, and then you take those learnings to adapt the landscape of possibilities, and then take the path of value, right? Based on the learnings on it. So you'll start off and, okay, like triple modular redundancy. I don't know anything about this problem. I'm going to implement it. Awesome. And then you're like, well, you know, it turns out that maybe if I use 2 threads and I do this other thing with 1% more hardware, that might be better, right? Because we can solve the performance issue, accelerate the checking mechanism, and then, but that's not what you thought was the right answer. You thought having 3 threads was the right answer, and so you need to adapt what you do, right? And you build a philosophy and a culture for what it means for you to be a researcher. And I have a couple tenets in my philosophy that I believe in, and I'll talk about one of them now, and then I'll get to some super practical advice as to how to get an academic job. As a student, I'll get to super practical advice, but I'll just talk about one tenet of my philosophy, and it's part of the culture we built at University of Michigan. So when you think about it's a community, right? It's an academic community. When you think about the community, like we publish papers, they might get rejected, they'll likely get rejected statistically. And you're on this journey and you're almost like, the natural thing is to think, oh, they reject. You care about your work so much, especially as a grad student, you care about your work so much. And you share it with the world. You're vulnerable, right? You expose yourself to the world, they say a bunch of nasty things, you instantly get defensive, and you're like, no, you didn't get it. You didn't see the value in my contribution. Even if there's a little thing there, you're nitpicking on silly things. But the way that I look at it, and what I advise my students to do is to see it as a dialogue, right? You're not just submitting what you think is good and they get to answer you. It's not a trial. It's really a conversation that's a super slow version of email, right? And that slow version of email is paper submitted, reviews back, right? And so you engage this dialogue, and you don't give up. So one of the key important things that we do in our group is top tier only, right? Top tier conferences only, right? You spend so much time of your life. This is controversial stuff. A lot of people are gonna be like, Jason, no, there's narrow areas, you got a better community, it's a debate. But for you and your career, top tier papers only, and I believe that the only difference between a top tier conference and a second or third tier conference, the only difference is the level of rigor that needs to be applied to your ideas. There's no difference in the goodness of an idea, and honestly, I've looked at the proceedings of some of the what is regarded as second tier or third tier conferences, and the ideas are phenomenal. And the execution may not have the same level of rigor or scholarship applied, right? That's the only difference. So, good. So become a ninja researcher. It's an art, it's a technique, right? Go to the Shaolin School of Ninja Kicks and become the best ninja you can when it comes to how to apply rigor to an idea. What is sufficient evidence? How do you articulate and frame the story in the context of what others are doing and what you're doing? Learn those crafts, right? And you learn them well. Good, now that you have those crafts, you are empowered to have this dialogue. You make a submission, you will get feedback, you'll likely be rejected. Internalize that feedback. Do what is needed to improve the level of rigor of your work. Just do it, right? Just do the things that you get. If there's something that you don't get, have a response in that dialogue and have it at the level of rigor as you need. And guess what? We've had papers that we've submitted for 2 years or so, 3 years or so, that ultimately get awarded the best papers on its final acceptance, right? Because it's gone through that rigor. Sometimes there's a timing thing, right? And this is very, very, very careful. I'll give you a concrete example. You guys could look this up. Controversial. Well, I mean, this is just really me just being very vulnerable. There's a paper called Deft NN that we published either ISCA like last year or the year before. It's really, it's ideas around, it's essentially an approximate computing paper, right? And we submitted it for like 2 years, 3 years as an approximate computing paper. But the result is you actually don't end up losing accuracy in a significant way with some of the optimizations where you skip work, right? And so we took that paper and we reframed it not as an approximate computing contribution, but as a kind of software acceleration techniques for neural network models. And it's the same content, same evidence, et cetera. And it got almost all accepts when we reformulated the story to not emphasize approximate computing. Now that's part of that craft when it comes to, you have to understand, and this is almost, it's kind of cynical, you have to understand that there's a market that has to consume your work, right? And so you don't downgrade your papers, right? You really try to understand how you need to articulate yourself in that intellectual dialogue. Now, okay, how do you not go? I'll give you some concrete stuff. How do you not go crazy as a student, right, doing this? Because, often you'll say to a student, okay, in this lab, we believe that it's the rigor of your work that determines whether or not your paper should be top tier or not. And we don't tolerate rigor of work that isn't top tier in this group. Okay, good. You're like, interesting advisor, fine. And then you're like, okay, I'm gonna go on that journey, but you're a freshman, you submit papers for 2-3 years, and they're not getting in because you're learning to be a ninja researcher, your papers aren't getting in, and then 2-3 years later, you're like, I suck as a grad student. Like, I really suck at this. I don't like to put my soul out into the world and get crushed for years on end, and maybe there's something wrong with me, and it's a completely grueling experience when you do it a certain way. So what I advise my students, and this is very controversial, I've had a lot of debates with other faculty about this. There's all kinds of issues. There's talent inversion, right? You'll see a student in another group get a paper year one, they're working on a sexier problem, you're working on a harder problem that maybe isn't as palatable, maybe approximate computing and it's like 10 times harder. You're getting rejected for 3 years, you think you suck more than they do, right? They must be great, look at their papers, right? But they have like the first 3 specialization papers when the specialization trend started. You know what I'm saying? So you might actually think you're not good when you're amazing. And so how do you mitigate this? Here's some really practical, controversial advice. There's something I have students in my group do. I call it paper level parallelism, okay? Paper level parallelism. Diversifying your portfolio. So when a student, all the projects are scoped, mean time to paper, MTTP. It's another metric we have in our lab, right? Mean time to paper should not be 3 years, right? And at least in my lab. You get to select the problems you work on. And so find exciting problems, but find exciting problems where you can go through that journey of exploration, experimentation, scrutiny. As a student, to optimize for a faculty job, 6 months mean time to paper, good. Of a, let's say second year student, it'll take a first year student longer. You pair them up so they learn, et cetera. You co-author with as many people you can co-author with, so you learn. You're growing. That's your number one objective. So when you submit that paper 6 months in, you stop working on that line of work. If you continue, here's what happens. Here's the kind of an average case. You're working on that paper, and that paper has a whole story. It's a dissertation, really. It's one element in a dissertation. You work on that story, you get on, you're excited, I love my paper. My manuscript is so amazing and the contributions are so important and I poured my heart and soul into it. You submit it and then you start working on the next steps on that journey. And then 6 months later, you get a rejection back, let's say, and then you're like, oh crap, that 6 months of work after the submission, you'll often end up either rolling it into the paper to make the paper bigger, or you'll do these things and then you send it out again, and 2 rejections is a year and a half on that journey. 3 rejections is 2-3 years. And you're not making that contribution. You're not doing well as a PhD student. So what I recommend is you should have 3 threads. When you do that 6 months mean time to paper, submit the paper, start another thread where there's not a dependency in the ordering of which paper gets in first, right? They're separate, enough that you don't have that dependency, so you don't end up rolling things into each other. So then 6 months in, you have 2 manuscripts. And I reward students for the manuscripts they generate, because if the manuscript goes past my bar, I know it's rigorous. So don't think you've won. I try to get them to not think about the accepted papers as the prize. It's the written manuscripts as the prize. And maybe 1 in 10 of our manuscripts don't ever make it, right? And with that top tier requirement. Maybe 1 in 10, right? So the mindset is your manuscript is a win. You've got 2 manuscripts now in 1 year. Rigorous manuscript, 2 ideas in the market. Go to 3. PLP over 3 is, race conditions or something, right? Like, if you're having a dialogue with 3 dialogues with the community, and none of those 3 dialogues are succeeding, something's wrong with the group, with the whole group, because we're a team, right? So MTT to 3, PLP to 3 is kind of the phrase. You get your PLP to 3 as soon as possible as a grad student, because what you'll see is you will not be able to predict your retirement. What will retire? The paper you love the most, I'm telling you, this is like always, I don't know why, it's the weirdest thing. The paper you love the most will often have the most trouble in that dialogue with the community. And then papers that you were like, I have a paper like that. So we started a thread of work. I'm gonna share, dude, and like, you guys are gonna be like, oh my God, Jason said this crazy thing that no professor would say. Like, I'll point to one of these lines of work. We did some work on cooling data centers with phase change materials. That work got in first try every time. I don't know why. Because I have works, like I have a work, Protoss. So protein code was one line of work that we did, where it's a dynamic compiler with 0 overhead, so you can recompile your code for free. Like that's a thing. Go check the paper. And then we created an operating system that's compiled like this continuously, and then we used it for address space randomization, right? Security measure. That paper is not published. Actually, the first time we submitted it, it got 4 accepts and 1 reject. It got rejected, and then the student graduated, Mike Lorenzano, and then I don't know. We submitted it like twice, and it didn't get in, and the student graduated. And that paper, by the way, is one of the best papers I think the lab has ever produced, not published, right? So the point is, you'll never know what retires in what order. But that diversity of work will keep you sane, because you will be having works land, right? In this journey, when you learn the rigor under a great mentor, you will have works land. And professors get this for free. Like, we have student level parallelism. Right? No, right. So you have to take care of yourselves, guys. You got to take care of yourselves. How can you get that parallelism, the advantage of that parallelism as a PhD student? So for us, it's like, fine, right? But for you, having that diversity will allow you to mitigate what I call talent inversion. The stronger researcher with better ideas and a better way to execute high quality, rigorous scholarly research will, with a diverse enough portfolio of work, will emerge more properly than when you put all your eggs in one research basket as a PhD student, right? And so that's actually the main mechanism for why, so we've graduated, Lingjia and I, we co-advise all the students. We've graduated 10 PhD students so far, and many of them have records that could make them faculty, right? And the community has been very interested in potentially hiring some of my students because we started this startup journey, and it's so interesting. A lot of students came to the startup, and we competed. I got to tell you, Yinchi Zhang, he wanted to go on the market. We gave him an offer that's like 2 professors worth and a crap ton of equity, right? Because we compete. I don't coax my students into coming. I'm like, students, you go, you interview, you do whatever. We're just gonna have a really good offer for you. And so that's, and then I'll let the offer just compete, because I don't want to coerce anyone. But, so those are like the key tricks. But just to kind of recap, how much time do I have? No, 3 or 4 minutes. Just to recap, right? On this journey is bigger than a job. The journey is bigger than that thing that you're doing. This journey is how you reconstitute yourself to be an intellectual. That's what you're doing, right? So that's awesome. You're going to be a better human being at the end of that journey. Then one of the most important things is identifying the right kind of mentors. And to do that, it needs to be folks that have an irrational interest and care for you, right? They're not going to get something in return, right? Mentorship will allow you the inputs that you need to grow maximally, okay? So do that. When you're at grad school, understand that when you engage the community, it's a dialogue, right? Treat it as such. And don't give up unless you're truly convinced intellectually that there's something at the core of your idea that's broken. You continue that dialogue, you improve the work, you make it more rigorous, more scholarly every step of the way. To keep sanity, make sure you have a diverse portfolio of research that you're doing. Because it's incredibly difficult to predict which papers will land when. And if you go for a very long time pouring your heart out to the community and getting consistently negative feedback, it's going to affect your psyche. It's going to affect your morale, right? And so, with just a couple of those tips, I'd be more than delighted to take a couple questions.
So we have about 10 minutes for questions for Jason. I imagine there will be many. Anyway.
You mentioned that it's important to work on different topics and to diversify your research. Do you have to see exactly how those different topics are going to fit into your dissertation beforehand? Seems like you're explaining.
Yeah, absolutely. And
Can you repeat the question?
oh, absolutely. So the question is, okay, working on different topics has benefits, but how do you rationalize that or reason about it when you have to write one dissertation, and can all that work fit into one dissertation? I believe absolutely it can, and it often does, and it really depends on how you approach your dissertation story, right? You could have a principle that could address many problems, right? And so that's a way that you can kind of have a diverse portfolio of ideas that don't have that dependency, right? And you can also have one problem with many areas that need to be solved. For instance, just a concrete example is, like, one principle that can solve many problems could be, like a style of computing, right? A new kind of computer architecture. And then it's application domains and, low power, high power, big, right? And so you can kind of diversify. Or you could have one problem that requires work on maybe a compiler, work in the OS, work on application, and then if it's the right kind of scale of problem, you might be able to have your application, your OS, and your compiler paper all going in parallel, right? So you do put some thought in what do you first author next. You co-author as many as you can, right? Because you will learn. You will get more breadth of understanding of the landscape of research when you engage on many projects. Like, it'll grow you. So you always want to co-author and collaborate. But the papers you first author on this journey is going to be your dissertation work. And you're just thoughtful about, there isn't a dependency to that other paper, but it fits into a bigger story. Yeah.
So I love this paper level parallelism idea, but I had a question. So do you expect, like, some of the paper level parallelism threads to, like, fail, or are they all expected to retire at some point?
Yeah, no. So in our lab, we never expect any thread to fail. And honestly, even if a paper appears at a lower tier conference, we'll call that a fail. We don't expect any of them to fail. The thing is, that's the bandwidth, is 3, right? And you might have a paper in your pipeline for 4 years. We've had that. There's a paper, WhereMap. Oh my gosh, when I was a student, WhereMap, it's like ISCA 2014. Literally, that paper was submitted for like 4 years, right? Like, and it was in the thread. But what'll happen is you'll start to maybe you'll have two thread slots that are kind of retiring and one weird lingering laggard, and they're not usually that common if you have a discipline as to how you revise your paper. When you get that reviews feedback, I tell students it's gold, right? Find the thread of things that's common, fix all of those all the way. Anything common among reviewers, fix all of those all the way. Anything that you intellectually agree with, must fix, right? You can't write around. Now, if there's some weird, obscure things in those reviews, you may be able to mitigate those in other ways where you don't have to like rebuild your experimental framework. But if you do that well, the expectation is all your papers will retire. And you'll have 3 threads, right? So you'll be able to let your work happen. But I always leave it to the student if they want to kill one of those threads or if they want to go beyond 3 and do 4 threads. You know, like sometimes students get sick of papers, and so then I'll actually I'll say, if you're sick of the paper, say you don't want to work on this anymore, and then I'll have another, if I believe in it, which I usually do, I'll have another student work on it. There's a paper about it's a universal tiling. It's a loop tiling paper. It's like a micro, right? And you don't see a lot of loop tiling papers. What is the universal tiling something paper? Like that paper was a paper that a student was like, I don't want to work on loop tiling ever again in my life. Like nobody accepts loop tiling papers. And I was like, fine. But if there's true value to your work, you should be able to, so that went to, and it ended up being a micro paper. So, yeah, good question. Oh.
So it seems like your mentor has kind of found you. Am I wrong? Did I follow you wrong? And then also the other question is,
That's a good question.
which way are you suggesting for people to find resources in
Yeah.
a big life decision and their particular time?
Yeah.
I mean, you're talking a lot about somebody who interactionally loves you, I guess, but
Yeah, how do you get there? Yeah, exactly. That's so true. Yeah. That is a super fair point. That is a very good point. Like, it's not like you're like, hi, and then they're like, I irrationally care about you. You know what I mean? Like, it's something that like has to be built, and how do you find mentors, right? And, honestly, mentors are usually earned. The way to find a mentor is, like, I can be a mentor, right? So you guys saw this interesting dude. Like, assuming I'm interested, it may not be interesting to you, but whatever. You saw this guy. You're like, that guy, I like his ideas. And then there are steps you have to take to earn it, right? In that you can reach out and say, yo, what's up? You can chat with me. That's good. But then it's like, if you take one of the paper ideas that I'm working on and then you challenge it in an interesting way and send me some data, I'm going to be very, like, I will remember you. I will be like, that's an interesting person. And if, like, they're in the vicinity, I'll be like, I kind of want to have a chat. That person needs to spend a summer with me, right? And then, so, like, you do something interesting, and then you just create a relationship, and it really is a lot like making friends. It really is a lot like making friends. Like, sometimes you're just not going to like the person, or, like, or sometimes you will like them. And it's make friends you admire. And out of those friends you admire, mentors will emerge, right? And it comes from internships. When you go to a Google, I didn't discover Robert Hund right off. I chatted with a bunch of engineers, and I just made some friends. And I challenged some ideas or something, and then you start to have more chats, and then a mentor emerges, right? So it's a relationship, and it's a lot like making friends. But just surround yourself with people who you can look up to, admire, and aspire to be, and then mentorship will emerge. From my perspective, yeah.
you mentioned that it's really important to articulate your work. Do you have some advice for that? Like, are there certain techniques that
Absolutely. Actually, one of the first seminar classes I taught when I became a new professor it's a paper reading class, but it really was a paper deconstruction class, right? And this is how I learned to write papers, guys, right? God. I mean, I don't want to sound weird, but like if you look at, I had to find clever ways to improve myself, and the source code is out there was a principle that I have. Like you find the best paper awardees, and you deconstruct them. What I tell my students is, okay, you're writing a paper. Find a model paper with a similar architecture of paper that your paper needs to be. And when you think your paper is close to as good as that paper, then we'll start talking, right? And so you deconstruct the paper, and I deconstruct intros, dude. Like in the class, we discovered something, and it's opportunity arguments and crisis arguments. And if you look at the best papers out there, And most things can be framed as an opportunity or a crisis, right? I'm not kidding. Crisis arguments will help your papers get in a lot. And you can take anything. Oh, there's a 15% opportunity if we use this clever idea. Or, oh, if we don't get 15% in the next year, our industry is going to die. Here's one thing that can save us from that, right? So taking any paper idea and framing it as a crisis, articulating what happens if we don't do this as a bad thing will help your papers become more compelling. Juxtaposition to prior work. There's something I call a magic table. We've gotten papers rejected, and I'm like, all right, throw a magic table in it, you know? And the magic table is you put all of the right relevant research works, and then you put all of the features and differences, and then you have checkboxes for what you check and what they don't check. And that'll help you with related work arguments. There's a rigor to experimentation where we try to overdo our results. Like, just go more than necessary from your opinion. Throw some sensitivity analyses that are interesting and talk about them in interesting ways. Make the paper compelling. So those are some just quick tips, but happy to chat, yeah?
We have time for one more question.
Yeah, just a quick question. So how do you measure time? I mean, you're being a faculty, you're being a professor, and at the same time, you're being a CEO at a very hot startup.
Yeah.
So, I mean, I mean, for one job, that could get crazy.
Yeah, yeah.
How do you manage two jobs?
Yeah, no, that's a phenomenal question, and I got to tell you, one of my secrets, guys, and this is going to sound weird. One of my secrets is, go ahead. Oh, the question is, how do you manage your time? You're doing like all these different things, and it seems like any of them can make you crazy. So how do you do all of them? And so one thing that I've done, because the way that I went out into the world to identify my spouse was very thoughtful, right? In that I'm kind of crazy and ambitious like this, and you know, I need to find another crazy ambitious person. Like, that's the style, and I'll work through the arguments because you're going to argue a lot. And there's many different models for success, right? You can say, well, I'm crazy ambitious, and I need someone who's going to take care of the kids because it matters to me that nannies don't raise my kids, right? Like, so that's a value that I'm not as strong on. You know, so we have like nannies and stuff, but picking your spouse is going to be a great enabler. So Lingjia and I, we team up. We team up on all of it, you know, and we're all in, and we shop talk all the time. And when I'm like, I don't want to travel because I miss my kid, which happens a lot, which is super sad. Please don't shed a tear, but I don't want to travel because I miss the kids. Lingjia's like, Zayden's gonna be fine, you know. Like, I'll be with him, and we're going to the zoo. So just go on that trip, come back, then we'll go to like a little vacay somewhere, right? And so we're aligned on this journey, and so we can do it together. And the sum of the two of us is bigger than the parts. So that's one key thing. And you have to have purpose, right? And my purpose is to like make one dent in technology, and like, so that purpose helps too. That's the best I can do. Thank you, though. Thanks for the question. Yeah.
All right, let's thank you.
Thank you, guys.